Paper 2 Honors Lesson 3.1 Graphing Systems of Linear Equations. Here are the objectives for the lesson. Now, to graph a system of linear equations, we need to get each equation in slope-intercept form. Now we know slope-intercept form is y is equal to mx plus b. Okay, y is by itself and positive. So for the first equation on top here, right, we need to get y by itself. So we're going to minus 2x. We're going to get y is equal to negative 2x plus 5. Right. For the second equation, right, I'll do it in red. We've got negative x plus y is equal to 2. We want y by itself, so add x. Y is equal to x plus 2. So both equations are in slope-intercept form. So let's find m here. M is going to be negative 2. Remember, if it's a whole number, put a 1 underneath it. And b is going to be positive 5. Over here, m, remember this imaginary 1, is equal to 1. Put a 1 underneath it. B is going to equal 2. So now we're going to graph both these lines on the same graph. Alright, so let's graph the first one right here. So I'll do it in blue. So we've got b is 5, so we're going to start at positive 5. Alright, on the y-axis. Slope is negative 2 over 1. That means we move down 2 over 1. Alright, so that's our line. So let me make a line right here. Okay. Now the second one, b is positive 2. Here we go. Right. So I'm going to start at positive 2. So let's put it, make it red. B is positive 2. M is 1 over 1, so we move up 1 over 1. Okay. And then let's make our line. Right. Now, where the two lines intersect, so this point right here where the two lines intersect, this point right here where the two lines intersect is your solution. So the solution, the coordinates of this point right here where the two lines intersect is 1 and 3. X is 1, y is 3. So this is your solution. So this, alright, so 1 and 3 is the solution to this system. And if you want to check it, alright, remember this is x and this is y. Plug it in here. Does 2 times 1, alright, that's 2, plus 3, does that equal 5? Yep. Over here, does negative 1 plus 3, does that equal 2? Yep. So you know that's correct. Okay? So when you want to solve a system using the graphing method, right, get each equation in slope-intercept form, find m and b, graph both lines on the same graph, and see where they intersect at, and that is your solution. Sometimes you could classify different types of systems without having to graph them. Alright, now there are going to be 3 different types of solutions. Okay, if two lines intersect, there's going to be one solution, obviously, because they'll intersect at only one point. Okay, so they intersect at one point, so there's one solution. Alright, so you can have one solution. Alright, now if they're the same line, alright, basically you have the same line, alright, on top of each other, that's called infinitely many solutions, or you could just call it many solutions. And if they're two parallel lines, if the lines are parallel, alright, if the lines are parallel, then you're going to get no solution, because if they're parallel, they will never touch. Okay, over here, if they're the same line, they touch in many different spots. Alright, they're going to touch right there, right there, right there. That's why there's many solutions. Okay, now how can you tell if all you have are the equations? Well, first of all, alright, so here are the characteristics. You know you have one solution if you have different slopes. Alright, if you have different slopes, alright, you're going to have one solution. Okay, if you have two equations with different slopes, you know you will have one solution. Over here, if you have same slope and same y-intercept. Alright, if you have same slope and same y-intercept, obviously the whole equation, both equations are going to be the same, right? So you know you're going to have many solutions. Alright, over here, if you have the same slope but different y-intercepts, you know you're going to have no solution. So same slope, meaning the lines are going to be parallel, but you have different y-intercepts, you're going to have parallel lines, so you will have no solution. Okay, so for example, your different slopes, let's say you have y is equal to 2x minus 4, y is equal to negative 3x plus 1. If you see different slopes, right away you know I'm going to have one solution. If you have the same slope, y is equal to 3x minus 5, then also you have y is equal to 3x minus 5. Same slope and same y-intercept, you're going to have, it's the same line, so you're going to have many solutions. And you have the same slope, let's say 2x plus 4, and y is equal to 2x minus 1. You have the same slope, so they're going to be parallel, but they have different y-intercepts, so they're different lines. Alright, so parallel lines are never going to touch, so you have no solution. Okay? So just make sure the equations are in slope-intercept form. That's the easiest way to identify how many solutions you'll have without actually having to graph it. So let's classify this system right here. Alright, well, the first one's nice because y is already by itself, so it's in slope-intercept form. Let's get y by itself for the second one, so let's add 2x right here. So we're going to get y is equal to 2x plus 1. And the top one we had y is equal to 2x plus 3. Well, what do we have here? We have same slope, different y-intercepts, so we know the lines are going to be parallel, so we know we're going to have no solution, because they're parallel lines. And then down here for these examples, all you have to do, make sure you get y by itself, slope-intercept form, for both equations, then you can compare them.